Okay, so yesterday we discussed about scoreboard, monitor, and agent. Okay, similarly, we have another component called environment. Okay, environment is a container class. Okay, what it contains? It contains agent, scoreboard, and then whatever the agent components we have, monitor, driver, sequencer. So all the components are built in our environment side only. Sometimes we will also add the coverage feed details. Okay, coverage file also it is built it in your environment side, and sometimes subscribers also we can build. Okay, reference model also we can build. Okay, coverage file also we can build in environment side only. Okay, see, the environment is a container class. It contains one or more agents. Agents means if you are having active agent or passive agent, whatever the agent you have, you need to design in the environment side only, as well as other components such as scoreboard, top level monitor, and checkers. All these things we are built in environment side. Okay, so this is my class representation. Okay, so class registration, for the registration we are using dynamic macros. Okay, during runtime using factory registration we are registering our class during runtime. Okay, so by using factory. Okay, so take component details, memory reference model. Similarly, custom constructor. Custom constructor, we are getting the parent components here. Function new string name and component parent. This is a component, right? So that's why string name and component parent also exist. Similarly, we need to create the handles for your agent. Okay, whatever memory agent is there, for that I'm creating the memory agent handle. And memory scoreboard is there, memory scoreboard. If you have reference model, memory reference model, you can represent the reference model. If you have any checkers, all these things, you can also represent the handles for that and create the object, so by using create and type ID method. Okay. So memory agent equal to memory agent scope resolution type ID create memory agent comma this, because this is a component. Okay. For that we are using this. Similarly, memory scoreboard equal to mem scoreboard scope resolution type ID create memory scoreboard. Okay. So this is the connection. And then see, connecting monitor port to scoreboard port. How we are connecting? We are having some item collected port, right? Item collected port is implemented in monitor side, and then item collected export we are implemented in scoreboard side. Okay, so then how we are connecting? Memory agent dot monitor dot item collected port dot connect memory scoreboard dot item collected export. Okay, so this is the connection from monitor to scoreboard. So during connect phase we are connecting all these things. Okay, see how we are representing the environment custom constructed. This is the complete code. So how we are representing class registration, and then handles of agent and scoreboard. So factory registration, after that custom constructor. Okay, and then in build phase we are creating the memory. Okay, so memory agent is equals to mem agent scope resolution type ID create mem agent comma this. Similarly, my memory scoreboard mem scoreboard type ID create mem scoreboard this. Okay, whatever the handles you have created, for that you are creating the object in build phase. Okay, function void build phase phase and super dot build phase. Okay, after that we are connecting them memory to, so monitor to scoreboard in connect phase function void connect phase phase. See, memory agent dot monitor dot item collected port dot connect memory scoreboard dot item memory scoreboard dot item collected export. Okay, this is the complete code. Okay, so environment code. Similarly, test. Okay, test defines the test scenarios for your test bench. That means you are creating some sequences, either read sequence, write sequence, read write sequence, and reset sequence, concurrent sequence, random sequence, and then consecutive read-write sequence. All these sequences you have created. For all those sequences, you need to create the test. Okay. So how we are creating the test? So class memory model test extends UVM test. This is my class. Okay. So from UVM test is my parent class and memory model test is my child class. Okay. Whatever we are implementing by using this child class only. Okay. And then class registration. Take UVM component details, memory model test. Okay, so that is my factory registration, class registration by using UVM factory, and then custom constructor. This is common for every component. Okay, class registration, custom constructor. Okay, function new, string name, memory model test, and UVM component parent null. So and then super dot new name comma parent. Okay, so this is common for every component. So if your component, so we have UVM component parent is there. If it is object, we don't have this component parent. Okay, and then in test we are creating the handles for environment and sequence, because in test only we are having below the test we are having environment. Okay, we need to create the handle for the environment because environment is connected to test. In test we are creating the sequence. Okay, so sequence is outside the environment. Okay, so some of them are inside the test they are keeping, or outside the test also they are keeping. But come to the inside the test and then inside the environment, then inside the environment agent is there. From that inside the agent sequencer is there. So based on that sequencer only we are carrying all the sequence items who are generated by the sequence. Okay. Then I am creating the object by using create and type ID method in build phase for your environment as well as sequence. After that, we need to start our test. Okay, so sequence, wherever the sequence you have created, in that sequence we are starting in our test. Okay, in test only we are starting our sequence. So that's why sequence dot start where you are having environment. Okay, inside the test environment is there. Inside the environment agent is there. Inside the agent sequence is there. So through sequencer we are passing the sequence items. Okay, this is complete test code. Okay, class memory model test extends from UVM test and then UVM component parent memory model test and then memory model environment and sequence. Okay, for that custom constructor is mandatory. After that in build phase we are creating the object for this handles environment and sequence. Environment equal to memory model environment type ID create environment comma this sequence equal to memory sequence type ID create sequence. Okay, in task run phase UM phase phase dot rise objection and drop objections we are starting our sequence. Sequence dot start environment dot memory agent dot sequence. Okay, so this is the complete test. Okay, complete test code. The top is a module, right? So in top what we are connecting, it connects the DUT and then verification environment components. Whatever the verification environment components are there, all we are connecting here only. So top contains what are those, your DUT instance, because you are testing the DUT. Okay, how we are connecting the DUT to test bench? In top model we are instantiating our DUT. Okay, so through instantiation it is connecting to your DUT. Okay, and then interface instance. Okay, physical interface, whatever the interface we are having, for that interface we are having the instance. Okay, after that run test. In run test, if you keeping empty means it is executing all the tests. Okay, if you mention, if you want to execute particular test means you need to mention the test name inside this run test method. Okay, and then UVM config db, we are setting the config db for of virtual interface in top only. Okay, so in top we are setting the config db bottom the components we are getting the config DB. After that, clock and reset generation logic also we have, and then waveform dump logic. Okay, dump variables and dump files we are representing for uh, getting the waveforms. Okay, and then this is my top. Okay, so module top, test bench top, clock representation, bit clock and reset. I'm generating the clock. Always hash 5 means every 5 seconds your clock will be toggled. Clock equal to negation of clock. And reset generation. So initially I am in reset condition. Reset equal to 1. This is an active high reset. Okay, if it is 1 means all the signals are initialized to 0. After 5 seconds or 5 time units, I'm resetting my reset. Okay, so resetting the reset, then it came out from the reset condition. You are giving the values manually. Okay, so that is the reset rate generation. After that, memory interface handle in that clock and reset I'm instantiating. Okay, so create the instance of interface, right? Whatever the physical interface we have, for that we are creating the interface handle or interface instance. In that we are writing clock and reset. Okay. So after that, DUT instantiation. Whatever the DUT you have written in your design, so we need to instantiate here. Okay. All the signals we are instantiating by using name. Okay. By name we are instantiating. So dot is used, right? So dot clock of interface clock, dot reset of interface reset. Okay, so all these are clock reset, all these are test bench related, and then interface dot. So these are DUT related signals. Okay, so that is the interface instance we are representing. Okay, again, so config DB we are setting that UVM config DB your memory interface. Okay, virtual interface memory interface I am taking. Okay, virtual memory interface, for that we are considering, right? So and then set UVM root. So root your setting. Okay, root is the topmost class. Okay, root is the topmost class. In that root and we are getting that, and then star is for entire components. Okay, global representation. So and then VF comma VF. Okay, interface, this is your interface, and then you are setting the virtual interface VF. Okay, after that run test, initial begin run test, and then dump variables we have. Okay, end module, uh, we are ending the test module, top module. Okay, same way here also we have all the components. Let's see environment. See, I told you environment is a container class. Okay, what it contain a container. So it contains all the verification components. What are the verification components we have? So all the components it is connected. Okay, so that is the agent, scoreboard, coverage, all these things, and it's the top level container. So for your test bench architecture, because environment is the top level container, so in that environment only we are having all the components. Okay, so see, class, example environment extends UVM environment, and then registers with UVM factory. Whatever the class we have extended, that class we need to register. That is with UVM factory. Tick UVM component details, example environment. Okay, that is your class name. In the environment, whatever the handles I am having, agent is there, scoreboard is there, and coverage is there. For all these, I am creating the handles or instances. After that, custom constructor. Okay, inside that virtual build phase we are creating the object for your instances. What are those? Scoreboard, agent, scoreboard, coverage. Okay, agent, your class name is example agent, type id create agent comma this, and scoreboard, example scoreboard, type id create scope resolution create scoreboard comma this. Okay, this is the connection. In build phase we are connecting, and then connect phase, virtual function void connect phase, phase phase. Okay, super dot connect phase. So whatever that get type name, that is we are getting the by name method we are getting the details. Okay, and then connecting environment high is the verbosity level. Okay, based on that verbosity level it print the messages. Okay, and then connecting phase. In connecting phase, what we are connecting, item collect agent dot item collected code dot connect scoreboard dot item collected export. In this way we are connecting monitor to scoreboard. Similarly, monitor to coverage we are also connecting agent dot item collected code dot connect coverage dot analysis export. Okay, so this is complete environment code. Similarly, test bench code, sorry, test code. Okay, so what is the test code here representation? So test is the top level component. Okay, so test is the top level component and configure all the environments. Okay, and run the sequences to verify our DUT. Okay, in test only we are starting the sequences. Okay, whatever the sequence you have written, all the sequences are running in test only. Okay, class example test extends test. Okay, so this is your class registration. Okay, by using factory, tick component details example test. In the test, we are creating the handles for environment as well as sequence also. Okay, so here sequence is not represented, no problem. Okay, environment is handle is needed to create in your test. Okay, and then custom constructor, you know that. In function build phase, we are creating the object. Okay, creating the environment object. Okay, in build phase. So environment equal to example environment scope resolution type ID create environment comma this. Okay, same way. In build phase, we are setting the config DB. Okay, see in test only we are setting the config DB. In the previous top module also we are setting the config DB. See, uh, configure environment. So set agent to active mode. So how we are configuring the environment? Config DB your active. So active passive enum. Okay. So and then set this command in memory dot environment dot agent. In agent we are creating that. Okay, so in test it is going to environment dot agent. Okay, is active, then active, we are creating that. Okay, so that is the configuration environment. Okay, we are setting the configuration environment. Where we are setting configuration environment, that is agent. So your agent should be active mode or passive mode, we are checking that. Okay, so that configuration we are setting in test. Okay, and then execute the test. How we are executing the test? Task run phase, phase. See, simple random sequence, that is your sequence handle. Okay, simple random sequence you are executing. So phase dot rise objection this starting test, and then tick info you are mentioning that you are starting your test. Okay, and then verbosity level, say creating the handle for that, sorry, creating the object for that sequence equal to simple random sequence type id create sequence dot number of transactions, how many transactions you are giving, that we need to mention, and then start your sequence. Okay, in test we are starting our sequence dot start environment dot agent dot sequencer. Which sequence you are starting? Simple random sequence. Similarly, basic sequence also we can execute it, and read sequence also we can execute it while writing the test cases. Okay, then we know so that test is passing or not if it If that test is passing means your sequence is executing, and then stimulus is passed to your DUT. Okay. So this is your complete test bench architecture. What are the test bench architecture? See, how to run the complete architecture. So how to run the complete test bench. Use this to complete UVM test bench. So what we are using here, DUT signals, clock, reset, address, and then control signals. All are interface signals. Okay, and then top level test bench module. In top level module, module we are representing UVM module, top module, TV module. Import the packages. After that, clock and reset generation. Inside that interface instance, okay, DUT instance. After that, DUT instance, clock generation. You are generating the clock, and then reset generation. After that reset generation, we need to set the config DB. So set in the config DB interface. After that, we are running the test. This is complete test bench module. That is the top module. Okay. So these are the run commands. How we are running PCS, Verilog, NKP, ops per UVM 1.2. So in this way, we are running our test bench. Okay. So this is the complete summary of your test bench. What we are what we are creating. So modify example transaction to match your DUT protocols. So that means so extending our DUT, and then update your driver to implement actual pin wiggling, and update monitor to sample the actual DUT signals, and add protocol specific sequence, enhance scoreboard, and checking the logic. If you want to update your test bench and DUT, we need to modify all these components. Okay, so this is your complete test bench summary. So sequence items, that means transaction definition with constraints. And how many sequences are written? 6 different stimulus patterns we are written. Sequencer for traffic control. Okay, sequence and driver, between the sequence and driver. After the driver, it converts that packet level to pin level data. Monitor, it observes that and creates transactions. After that, agent encapsulates sequencer, driver, and monitor. Okay, scoreboard, it checks the correctness with the reference model. So in reference model, we are getting expected data, and then actual outputs we are getting from the monitor. And then coverage, collect the functional coverage. How many features are covered? All these things it is covered. Environment is a container to contain all the environment components. Top is a module where you can run the all the test cases. Okay, so this is your complete test bench.